Hello. Yeah, am I audible? Just let me know if I'm audible to you. Thank you so much. So today we will start with permutation and combination. I think most of you have studied this chapter. So I will not go too much into theory portion and we'll just briefly do the things, then we'll do questions. We all are aware that this chapter is all about the questions, isn't it? So quickly I go with fundamental principle of counting. So according to fundamental principle of counting, if a certain work A, just a hello. Yeah. So if a certain work can be done in M ways and another work B can be done in N ways, got it? Then the number of ways of doing the work C, which is done only either A or B. When either A is done or B is done, got it? Then it will be M plus N. Let me give you an example. Like I want to register a plot. I just bought a plot. Now I'm going for its registry. So this plot can be either in Jaipur or this plot can be in Vishakhapatnam. Got it? So there are two ways to travel to Jaipur and there are three ways to travel to Vizag. So in how many ways I can reach there and register the plot? So total 5 ways. Either I can register a plot in Jaipur or I can register a plot in Vizag, and there are 2 ways and 3 ways to reach there. So total 5 ways to get a plot registered. Got it? Now it is like the number of ways of doing a work C, which is only when both A and B are done, is Mn. Getting my point? Is Mn means C can be done if A is done as well as B is done. So in how many ways this entire work can be done? M into N. This is what we call multiplication principle. Got it? Now there is a notation we use, factorial notation, we all are aware of. Like 5 factorial will be 5 into 4 into 3 into 2 into 1. Just one thing generally we use, n factorial is n into n minus 1 factorial. Take a note of this. Or if required, I can write n into n minus 1 into n minus 2 factorial, like this. Got it? Now there is a term we use, permutation, NPR. NPR is what? A permutation is an arrangement of a definite order of a number of objects taken all or some at a time. In simple language, if I tell you, NPR is what? Number of ways of arranging R objects out of n distinct objects. NPR is what? The number of ways of arranging R objects out of n distinct objects. This is what we call NPR. Am I clear? So you are already aware of it. Now, what is the definition of NPR? NPR is what? N factorial upon n minus R. Like if I ask you 5p3, say like there are 5 students in a class, in how many ways you can make 3 students in like stand in a queue? So you select 3 students and you make them stand in a queue. So answer will be 5 factorial upon 2 factorial. That is 5 into 4 into 3 upon 2 into 1. So this is goes to, so 6 5 ja 30. So there are 30 ways. Am I clear? Now, the equations we will do in a while in single order. First of all, let's cover permutation and combination and let's talk about them. Now, the number of permutations of n different things taken are at a time when a particular thing is to be always included in each arrangement. Just a moment. So sorry, I don't understand what's happening today. So the number of permutations of n different things taken are at a time when a particular thing is always included in each arrangement. See, this result is r times n minus, this result is r times n minus 1 factorial. N minus 1 p r minus 1. So where did it come from? Good. See, one object is always to be included. So that means now out of n minus 1 objects, now out of n minus 1 objects, I have to select r minus 1, arrange them. Now after you arrange those r minus 1 objects, there will be r gaps in between. In those r gaps, a way of placing that always included object is how many ways? R ways. Got it? Now, next देखो, the number of permutations of n different things taken are at a time when a particular thing is never taken in any of the arrangements. So one thing you are not taking any time. So that means now you have to select r objects out of n minus 1 things and arrange them. So answer will be what? N minus 1 PR. Got it? This is the answer. Now, third, the number of permutations of n things, different things taken are at a time, allowing repetition is. Now, repetition is allowed. So it is like there are r places. Each place can be filled in n ways. So this place can be filled in n ways. This can be filled in n ways. This can be filled in n ways. And this is total r places. So answer will be what? N to the power r. Am I clear? Now, the permutation of n things of which p are identical of one sort, q are identical of another sort, r of identical of third sort is what? N factorial upon p factorial, q factorial, r factorial, and that's it. Identical objects, arrangement of identical objects. Simple thing is, that's good. We'll do questions about it in a while. Now, combination. Combination dictionary meaning is selection. Dictionary meaning is what? Selection. Like permutation, dictionary meaning is arrangement. Combination, dictionary meaning is selection. Now, here in this case, you are going to select R objects out of n distinct objects. What is happening in permutation? We are going to select R objects and then we are arranging those R objects also. Here we are only selecting NCR. So what is NCR is? What is NCR is n factorial upon r factorial and minus r factorial. Simple thing. Now you know NCR is NC and minus r. Selecting R objects or rejecting R objects, they are one and the same thing. Got it? This is very important. NCR plus NCR minus 1 and plus 1 CR. This is what we call Pascal identity. This is what we call Haskell identity. So NCR plus NCR minus 1 is N plus 1 CR. Am I clear? These few things you should definitely remember. NC0 is 1, NC1 is N, and NCN is 1. Got it? Now, few certain things about it you generally get used to in questions. First is the number of combinations of n different things taken r at a time when p particular things are always occur. That means p particular things are definitely inside. That means now what you have to do out of n minus p things, you have to select only r minus p things. So it is n minus p, c, r minus p. Got it? Now, the number of combinations of next is number of combinations. Okay, just one example I would like to give you. Say there are total 15 players. You need to select 11 players to make a team, and it is given that a particular player is always in the team. So that means out of 15, if one player is already there in the team, that means out of remaining 14, you are going to select 10. So what will be the answer? 15 minus 1, C 11 minus 1. That is why this N minus P, C R minus P is included. Am I clear? Next, the number of combinations of n different things, taken are at a time when P particular things never occur. So P particular things are never included. That means you are going to select R things directly out of N minus P things. So answer will be N minus PC R. Am I clear? Now, total number of ways of selection. Total number of ways of selection is like you have 10 objects. Now, in how many ways a selection can be made? See, I do not select any object is a choice, is a way of selection. Or I select one object, or I select two objects, or I select all n objects. This is a way of choice for me. Got it? And this is equals to what? 2 to the power n. Why it is 2 to the power n? See, with the selection point of view, you do not select any object, or you select one object, or you select two objects, or you select all n objects. Got it? That is a way of selection. But with the object point of view, each and every, with the object point of view, each and every object has two ways. Either it is selected or it is rejected. Each and every object has two ways. Either it is selected or it is rejected. So that is why it is equals to 2 to the power n. Now, the number of selections of 0 or more things out of n identical things. Definitely. Now, if there are 10 identical things, so ways of selecting all 10 things is one way. Ways of selecting 9 things is also one way because there is no choice. They all are identical. Ways of selecting 8 things is also one way again. So total there are n plus 1 ways. Got it? Now, the number of selections of one or more things out of n identical things. So that is n, means they are rejecting the possibility of making no selection. They rejected that possibility, means either you select one way, or you select two one way, or you select three one way, or you select all n of them again one way. Got it? Now we'll do some questions. Those will be mixed type of questions. Your efforts will be appreciated. Keep trying. Find the number of permutations of the following words. First word is Ganga. So how many words can be formed, or how many ways this letters of this word permutation can be can be formed by reshuffling the letters of the word Ganga? Answer will be what? There are total 1, 2, 3, 4, 5. There are total 5 letters, out of which 2 are identical to G, 2 other are identical to A. So it is 5 factorial upon 2 factorial, 2 factorial. Got it? 5 factorial upon 2 factorial, 2 factorial. Now, let's come to another word, combination. Now see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total there are 11 letters. So 11 factorial divided by. Now, how many n? 2n. So for that reason, 2 factorial. How many O? 2. Again 2 factorial. How many COMBIATI? How many I? 2I. Except if there is no other word letter that is repeating. So answer is what? 11 factorial upon 2 factorial, 2 factorial and 2 factorial. All right. So this is it. Now, let's start with some more questions. How many four-digit numbers can be formed? How many four-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed? All right. How many four-digit numbers can be formed using the digits 1 to 9 if repetition of digits is not allowed? Now see. These are the 4 places you want to fill using 1 to 9 and repetition is not allowed. See, this place can be filled in how many ways? 9 ways. This can be filled in how many ways? 8 ways. This can be filled in how many ways? 7 ways. And this can be filled in how many ways? 6. So total number of words is how much? Total number of numbers is 9 into 8 into 7 into 6. Multiplication, so I think you can do. Yes or no? So total number of numbers are 9 into 8 into 7 into 6. What else we can do here? Directly answer can be 9p4. That's the same result. Because what you want to do, you want to permute 4 letters, here 4 numbers out of 9 available numbers. Got it? Next, if total number of 6-digit numbers in which only and all 5 digits 1, 3, 5, 1, 3, 5, 7, 9 appears is total number of 6-digit numbers in which only and all 5 digits must be there. Now see, I want to fill these 6 places. These 5 places. I want to fill total of 6-digit numbers, these six places using 1, 3, 5, 7 and 9, and definitely one digit must be repeating. So first of all, what we do, I will select out of 5 one digit. Out of 5, I have selected one digit. Now it can be any of the 5 digits. So now let us assume we have 1, 3, 5, 7, 9, 9. Got it? So in how many ways? In how many ways these digits can be arranged so that we get a new number? So that we get a new number. So this, now 6 objects are to be arranged at these 6 places and there are one number which is repeating. Got it? So answer will be what? 6 factorial upon 2 factorial. Check again. 6 factorial upon 2 factorial. Got it? Now, how many odd numbers less than 1000 can be formed using the digits 0, 2, 4, 5? without repetition. Now they are saying how many odd numbers. Now in this case, odd number less than 1000 means either it will be a 3-digit number, or it will be a 2-digit number, or it will be a single digit number. Got it? So how many odd numbers less than 1000 can be formed? 0, 2, 5, 7. Now see, this place can be filled in how many ways? Two ways. 5 or 7. This place can be filled in two ways, 5 or 7. Now before that, this place can be filled in how many ways? Achha, before that, I will fill this place. Because now repetition is not allowed. So this place can be filled in for 2. So this place can be filled in two ways. Why 2? Because repetition is not allowed. One place has already been occupied at the unit place, and this place cannot be 0. Now this place can be filled in further how many ways? Two ways. So 8 numbers are there. Now 2-digit number may this place can be filled in two ways, 5 or 7, and this place can be filled in again two ways, because 0 cannot come, and the number which occurred at the unit place, that can also not come. So answer will be what? And now this place, sorry, 2 to the 4. And this place can be filled in two ways. This is 2, 5 or 7. And this single digit number, it is the two ways. That's it. So your answer will be 8 plus 4 plus 1 plus 14. So there will be 14 numbers less than 1000. See, the important thing here is you also have to check the numbers which are 2-digit and single digit. Got it? Now, next question. There are 8 daily newspapers and 5 weekly magazines. 8 newspaper and 5 weekly magazine. If student Stephen wants to subscribe to exactly one daily newspaper and one weekly magazine, how many different choices does he have? So in how many ways he can subscribe to a newspaper? 8. And in how many ways he can subscribe to magazines? How many ways? 5. 40 ways. Now, find the total number of ways of answering 5 objective questions type. Each question has 4 choices. Every question should be answered. Of answering 5 objective type question, each question having 4 choices. Now I am assuming that this is a single correct objective type question. Objective type question. Got it? So each question has 4 choices, out of which 1 is correct. So total ways is what? 4. Second question also 4. Third question also 4. Fourth question also 4. Fifth question also 4. So it is 4 is to the power 5. That is 2 to the power 10. Got it? Now, how many 3-digit numbers can be formed without using the digits 0, 2, 3, 0, 1, 2, 3, 5, 7? Now see, your 3-digit number either will be with 0 or it will be without 0. So if it is without 0, the cases will be less. If it is with 0, the cases will be more. Now see, there is a 3-digit number you are trying to form. Three-digit number can be formed without using the digits 0, 1, 2, 3, 5, 7. Okay, without using the digits, you don't have to use it. Then fine. What we can use? 4, 6, 7, 8. Yes or no? Now, this place can be filled in how many ways? 4, 3. And this place can be filled how many ways? 2 ways. So 2, 3, 4. So answer will be what? 24. Got it? Now, let's move to more questions. All the letters of the word. Okay, before that, we will do some questions from dictionary ranking. Like there is a word as far I see in the list of the attendees, there is a name Rohit. As though it is TH Rohit, but I'm considering Rohit. Now the question is all the words formed by reshuffling the letters of the word Rohit. And T we have already many letters of the word Rohit are arranged in a dictionary at which place Rohit will come. Now see what do we do? First of all, arrange the letters in their dictionary order. H, I, R, T. This is it. Now, first of all, the word is starting with H. How many? 4 factorial. Then starting with I. How many? 4 factorial. Because now when starting with H, I, O, R, T will arrange. Now starting with O. How many? 4 factorial. Now R, U are required. Got it? Now fix R here and cancel from here. Now inside R, word will start with H. How many? Now R, I. How many? 3 factorial. R, O. This R, O wale how many? O I want. Cancel it here. Now inside O, word will again start with H. H. Cancel from here. I require. Cancel from here. T I require. Cancel. So you formed Rohit here. So at which place Rohit came? 24, 24, 24, 72 plus 12 plus 1. 85. So out of total 120 words, which were supposed to be filled by this, Rohit will come at 85th position. Am I clear? Now let's do a question where repetition of digit is also occurring. Now also in the list, there is somebody, Shetty. Shetty. That means whenever we arrange the letters of the word Shetty and arrange them in their dictionary order, at which place this particular word Shetty come. Got it? Again, same thing. First of all, arrange the words in their dictionary order. So H, before that E, H, S, T, T, Y. ठीक है ना? E, H, S, T, T, Y. First of all, those words will come that will start with H. Sorry, that will start with E. Now, at the remaining places, to arrange H, S, T, T, Y. How many ways of arrangement? 5 factorial upon 2 factorial. Correct? Now words will come which will start with H. 5 factorial again upon 2 factorial. Now S will come. So fix S here. Fix S, then cancel it from here. Now inside those will again start with E. So it is 4 factorial upon 2 factorial. Now SH. H I want. Fix H here, cancel from here. Now inside H, words which will start with E will begin. This is what you want. This cancel it here. Then T will come. I want this. Another T will come. I want this, and then Y will come. So one word for this. So how many words can be formed? This is 60, 60. This is 12, and this is 1. 60 and 60, 120, 132, and 1, 133. So 133 words will come. Yeah, or I should say 132 words will come before Shetty, and Shetty will come exactly at 133rd letter. Am I clear? Now see, if all the letters of the word MCOT are arranged in different possible ways, find the number of arrangement in which no two vowels are adjacent to each other. Now, first of all, if you realize there are 3 vowels E, A, O, and 3 non-vowels M, C, T. So first of all, if I realize there are 3 vowels E, A, O, and 3 letters which are not vowels is consonant M, C, T. So first of all, what should I do? The letters which I want to separate, arrange them later. So first of all, arrange MCT. So MCT ways of arrangement will be 3 factorial. Now out of those MCT, there are 4 gaps. So out of those 4 gaps, select 3 gaps. And at those 3 places, arrange EAO in how many ways? 6 into 4 into 6. 72 ways. Am I clear? Now, in a college of 3 students, every student read 5 newspaper and every newspaper is read by 60 students. Number of newspaper is. Now see, there are 300 students and every student read 5 newspaper. So total number of readings is what? 300 into 5. How many? 6,000. 6,000 readings. Got it? So 300 students and every student reads 5 newspapers, so it is 600 readings. Now, every newspaper is read by 60 students, number of newspaper. Now let number of newspaper is X. Now total number of readings will be what? 60X is equals to 6,000. X is what? So they are having 100 people who are reading or taking part in this survey. Got it? Now, the number of 7-digit integers with sum of the digits equal to 10 and formed by the digits 1, 2, 3. Now see, use your brain. In how many ways I can make a 7-digit? Repetition is allowed in that case. Sum as 10. Now see, one way is 1, 1, 1, 1, 1, 2, 3. What is the sum? Sum ho gaya 10. Got it? Now, is there anything else I can do? I can do it like 1, 1, 1, 1, 2, 2, 2. Sum is what? 10. Got it? So in how many ways their arrangement can be done? 7 factorial upon 5 factorial. In how many ways this arrangement can be done? 7 factorial upon 2 factorial, 3 factorial. Got it? Why? No, sorry. 4 factorial. Why I did 4 factorial? Because 4 identical ones. Why I did 3 factorial? 3 identical twos. Now there comes circular permutation. Circular permutation is like arranging people or distinct objects around a circular table. Getting my point? Now, why this case is quite different? See, in general, in linear manner, when we make the arrangement, there is an end defined. Like somebody start with first position, so it will be first position only, then second, then third will come. So their end is defined. But if I talk about in circle, there is no end. So if I say first any kid go and sit any of the chairs around the circle, he will go and take a chair. Now once he is sit, he has set a benchmark of like this is the end of the table. Yes or no? So in this case, one student who left and asked to sit anywhere is out of the picture now. Now remaining, say 9 students are there. 9 students can be settled around that circular table is what? 9 factor. Because once one boy is seated, so one boy is seated, so arrangement is, there's no particular way of arrangement for that particular one. After his placement, now others can start sitting and make a choice. Am I clear? So in that case, if n students are there, answer will be n minus 1 factorial around a circular table. Got it? Now, the number of different permutations of n different things taken all at a time is n minus 1 factorial. This is what I just told you. N minus 1 factorial upon 2. If clockwise and anti-clockwise order are taken as different. Undoubtedly, if you are placing people around a circular table, you cannot get confused between clockwise and anti-clockwise. It has to be taken up. But yes, now the different thing is, if you are considering clockwise and anti-clockwise different. So in that case, answer will be n minus 1 factorial. Dhruvi, Inchara, Dhruvi, can't you switch on your mic? Switch on your mic then. Anyways, now number of circular permutations of n different things taken are at a time when clockwise and anti-clockwise are taken as different. So R objects you have to arrange around a circular table. It is NCN minus R. Got it? N objects are there. So first of all, select R objects. Now selected R objects. So out of those total R objects which can be settled around a table is N minus R factorial. Clear? So NCR into, no, sorry. NCR into R factorial. But since this arrangement is not distinguish, it is distinguishes between clockwise and anti-clockwise. So we'll do by 2. So NCR R factorial upon 2 factorial. Now number of circular permutations of n different things taken R at a time. When do we do not consider clockwise and anti-clockwise as different? When we consider them as same. Like it is the case of garland. है ना? Mala, garland. Now, it does not have a choice. You place the garland like this or you place the garland like this. It's one and the same thing. Got it? So that is why in that case, clockwise and anti-clockwise are considered same. So in that case, answer will be n factorial upon 2 factorial n minus r. Clear? Now, a chord word of length 4 consists of 2 distinct consonants in English alphabet, followed by 2 digits from 1 to 9, with repetition allowed in the digits. Okay. If the number of chord words so formed ending with 432 ending with an even digit is 432 into k, then k is equal to. Now see, 4 consists of 2 distinct consonants in English alphabet. So first of all, let us select 2 distinct consonants. NC2 is what? Selection of 2 distinct consonants. And now 2 digits from 1 to 9. So select 2 digits from 1 to 9. There are 9 digits. Select 2 digits. And now in how many ways they can be arranged? So they can be arranged in 9 into 8 by 2 into n into there are 26 letters, no? So we'll make it 26. Got it? So out of 26, select 2. Just a minute. Consists of 2 distinct consonants. Okay. 2 distinct consonants in the English alphabet. So there are total 21 consonants. Vowels they are not considered. So it is 21C2 and out of 9, 2 digits 9C2. So this is your answer. Got it? Now 5 persons entered the lift cabin on the ground floor of an 8-floor house. So 5 persons enter the lift cabin on the ground floor of an 8-floor house. Suppose each of them can leave the cabin independently at any floor beginning with the first. The total number of ways in which each of the 5 persons can leave the cabin at any one of the 7 floors. There is 8-floor building. So they are getting down at floor number 1, 2, 3 or up to 8th floor. With the total number of ways in which each of the 5 persons can leave the cabin at any one of the 7th floor. No, it should be 8th floor. Ground floor is not considered into a floor. So 8 ground. All right, 8th floor. So see, if there are two things I'm telling you, if any person can get down at any one of the floors, any person can get down at any one of the floors. So first person can get down in 8 ways, another in also 8 ways, another in also 8 ways, and so on 8 ways. So 5 persons are there, so total 5 times. So answer will be 8 to the power 5. Now, if they are getting down at different floor, first can get down at one of the 8, another 7, another 6, another 5, another 4. This will be your answer. Am I clear? Anyways, thank you so much. We'll continue from here only tomorrow or the next class whenever we are having. So till that time, keep revising it. All right. So I just want a small feedback about this class.